Hello all, welcome to the new video. In this video we'll be seeing about SSB modulation, which is used in communication systems. So SSB stands for single sideband modulation. So till now we have learnt about AR modulation, and then we studied about the pros and cons of AM modulation. What we would do in AM modulation is we would send a carrier, and along with the carrier we would send our message signal. So this is the first set of modulation scheme which we encountered in communication systems. So now after studying the advantages and disadvantages of AM modulation, the next step was to learn DSPSC modulation. So in DSPSC modulation, what we did, that is double sideband suppressed carrier modulation. So the main disadvantage of AM modulation was much of the power was used to send this carrier alone. Okay, so majority of the power was used to transfer this carrier from one place to another. So the modulation efficiency was less. So for AM we can say modulation efficiency was less because carrier used to take a lot of power. So that was totally like not required. So what we did in DSPSC modulation was we suppressed this carrier. So we just transferred the required message signal. So this is how our DSPSC modulation looked like. You can see there is no carrier. So we saw about how to generate DSPSC signal in the last couple of videos. You can go through those. So this is DSPSC modulation. So as you can see, we have optimized till now. Can we optimize still more? So that's what all the scientists in communication system always look like. They strive for maximum efficiency. So first there was air modulation, then they thought modulation efficiency was less, so they thought of inventing another modulation which has more efficiency, that is modulation efficiency. So that's how DSPSC modulation was born. So it didn't stop there. So we can even increase the efficiency. So that's how our recent SSP modulation came into the picture. So we'll see about SSP modulation. So in DSPSC modulation, M of T, that is our message signal, will look something like this. Okay, and this is F. So after this message signal under this DSPSC modulation, this is after modulation. The frequency plot will look something like this. Say S of F, and this is Fc plus W and Fc minus W. This is minus Fc plus W and minus Fc minus W. So this is Fc. This is all F domain. So as you can see in DSPSC modulation, there is just a message signal and there is no carrier. So we have optimized the power. So what about bandwidth? As you can see, every signal has, this is USB and this is LSB. So a lot of bandwidth is being used in DSPSC modulation. So instead of sending both LSB and USB, we can just send either one of these. Okay, so that's how the new modulation scheme came into picture. So in SSB, that is SSB stands for single sideband modulation. So by single they mean either USB or LSB, because any message signal we can retrieve by knowing either USB or LSB. So in order to reduce the bandwidth, we use SSB modulation. So we'll see all the mathematical, that is the basic concept. We'll see about the mathematical equations and how the final equation looks like for SSB modulation. So coming to the equation is quite similar to the DSPSC modulation, that is m of t into Ac cos 2 pi fc t. So for single tone modulation, that is when message signal is of single frequency, m of t will look something like am cos 2 pi fm t. So this is a single frequency, hence the name single tone modulation. Okay, so s of t now will look like ACAM cos 2 pi fct and cos 2 pi fmt. So we use cos A cos B formula. There's a product of two cos functions to get the final S of t. So S of t will look like ACAM by 2 cos A plus B. So cos 2 pi fc plus fm into t. Okay, then plus ACAM by 2 cos 2 pi. Once fc is greater than fm, we use fc minus fm into t. So this is nothing but our DSPSC equation. So for SSB it is simple. For USB, if USB is transmitted, then our equation will be just up to here, that is ACAM by 2 cos 2 pi fc plus fm into t. That is, ignore this part. If USB is generated, ignore this part. Ignore. This is for USB. And ignore this for we transfer only LSB. Okay. So we can see. So this is how that is SSB modulation frequency scheme looks like when USB is transmitted. So there are two equations for SSB modulation. That is, as I told earlier, S of t is ACAM by 2 cos 2 pi fc plus fm into t. So this is if USB is transmitted, and S of t is the same as this, cos 2 pi fc minus fm into t if LSB is transmitted. So you can say this is how SSB modulation looks for this equation. This is the frequency picture. Okay, so we'll see about what is the power saving in SSB modulation, which is the popular question in every exam. So that's it for the current video. Kindly subscribe to our channel. Thank you, and please like our Facebook page. We'll be updating all the new videos on the Facebook page too. Thank you.